Hello, we're back again, solving for the algebraic expressions that we wrote using Kirchhoff's current and voltage laws. Alright, so down here I have the equations still written out symbolically, and up here I have written down what all the values of everything is that we know, and the three things that we're solving for. So let's go ahead and rewrite these three equations with numbers in them. Starting with I1 plus I2 equals IA. Well, we don't know I1 or I2, but we do know IA. So we can write this as I1 plus I2 equals 2 amps. So there's our first equation that we're going to write with numbers in it. So I'm going to erase the symbolic representation. And for this next one, it claims that 0 equals V2, which we don't know, minus I2, which we also don't know, but R1 we do know. R1 is 2 ohms. So 2I2 is the same as I2 times R1. Then we're going to subtract the current A, the current through the ammeter, which was 2 amps, times R2, which is 5. So we've got 2 amps times 5 ohms. And there's our second equation written in numeric form. Alright, one more to write down. This one claims that 0 equals I1 times R3. We don't know I1, but we do know R3. R3 is 7. And I1 we don't know, so we'll leave it symbolic. And then we're subtracting voltage from source 1, which was 15. If you look up here, or on your schematic, you'll see that. And then we're going to go ahead and add I times R2. Now we do know IA anyhow, forgot to write the subscript. IA times R2. IA happens to be 2 amps and R2 happens to be 5 ohms. So we're subtracting, or adding here in this case, we're adding IA, which is 2, times R2, which is 5. Alright, so let's go ahead and get this out of the way and start solving. So the 2 and the 5 here and 2 and the 5 here, I'm going to go ahead and make those both 10. Alright, there we go. We have two numbers here, negative 15 plus 10. If we go ahead and add those together, we're going to end up with negative 5. So this expression says 7i minus 5 equals 0. We could add the 5 to both sides and get 5 equals 7i, and then divide by 7 and prove that I1 equals 5/7 of an amp. So there is our first solution. Let's go ahead and plug it into another equation to figure out what maybe I2 is. Alright. So, I1 plus I2 equals 2. I1 plus I2 equals 2. I1 is 5/7. I2 is unknown. But we know that they equal 2 when they're summed together. So we could subtract 5/7 from both sides. And that will cancel on this side. And then we end up with 2 minus 5/7. We're going to rationalize the denominator and scale the numerator accordingly. 14 minus 5 equals 9, and the denominator is 7. So we've proved that I2 equals 9/7 of an amp. There's the second solution. And now we just need to solve for voltage source 2. And we could use this equation. Alright, I2 is 9/7. So we've got negative 2 times 9/7 minus 10 plus V sub 2 equals 0. So 2 times 9 is 18. That's negative 18/7 minus 10 over 1, and then let's go ahead and rationalize the denominator, multiplying both top and bottom by 7. Now negative 18 plus negative 18 minus 70 is negative 88 over 7. And then we'll subtract the voltage over to the other side. Minus V2 equals negative 88/7. Those negatives are going to go ahead and cancel. And lastly, you're going to plug this in to figure out what it is. Alright, there's my calculator. 88/7 is 12.57 volts. So V2 equals 12.57 volts. And with that, we've solved our three equations, three unknowns.